system, Hadoop file system. So now remember this point. So always in a Hadoop cluster, so we have some nodes are available. We call the nodes as a data nodes, where in each data node we'll have the two file systems. One is a local file system and other one is a SDFS file system. Then what local file system contains? Local file system contains the files which are related to the operating system. Right. Second thing, where we install the Hadoop, we install Hadoop in a OS. So Hadoop installation files, Hadoop executable files, Hadoop configuration files. So all the Hadoop stock configuration files resides into the local file system. Suppose you are looking for Hadoop configuration files, then try to locate those files in a local file system. Suppose we install a Hadoop component Scoop or HBase or Hive or Peak, Scoop, Uzi, Mohot. So these are the components which we are going to install. So from where we are going to install these stacks, these components? From the local file system. So these executable files, these binary files, the library files, so all these files are available in a local file system. So you have to remember the Hadoop stack, the Hadoop configuration files, or the Hadoop components configuration files, everything will be available in a local file system. Then what SDFS file system contains? The data which we are going to process, only that data resides in a SDFS file system. Suppose I have some data is available. I need to process the data to generate some output. So that data, the input data which we have to process in a Hadoop cluster, so that data must resides in a SDFS. You should make the data available in a SDFS file system. So clear now what a local file system contains? The file system contains OS related files and Hadoop stock files. Then what the Hadoop SDFS file system contains? SDFS file system contains the files which we are going to process in a Hadoop cluster. Okay, suppose as I said, I'm having a file, right? So how we are going to write the data? So I'm having a file. The file name is prod underscore info.txt. So this is my input data, input file. So consider I'm taking this file size as a 1000 MB file. Let's say it's a 1 GB file, the size of the file. Now it's available in my system or somewhere into the system it is available. Then I have to make the data available into the cluster. That is, I need to copy the data, right? So I need to copy the data. That is, I have to write this file to the Hadoop cluster. So how to write? See, generally in Hadoop, I'm having a command. Copy command is there, or you can use a command copy from local is a command is there. So with this command, I want to copy this file to the Hadoop cluster. So as the definition yesterday, what it is, Hadoop is a distributed data. That means the data which we are going to write to the Hadoop cluster is going to be distributed, right? So that is the input data. The input data which we are going to write into the Hadoop cluster is distributed, in the sense the input data is divided as small size of chunks, right? So we call these chunks as blocks, small size of chunks. So we call these chunks as a blocks. Then how many blocks it will divide? So when you install Hadoop, with the Hadoop installation, we'll get a one configuration file, that is sdfs-site.xml. In this configuration file, so we have a property. The property is dfs dot we have a property, that is dfs dot block. So the block size, so what is the block size default? So that means how much each block can be created in a Hadoop cluster. So we have a property dfs dot block. So this can be set to any value, like it can be 64, right? 120 is the default one in a new Hadoop cluster, or we can be it's a 256, or it can be a 512 MB, right? So you can set anything. So the default value that comes with Hadoop installation is 120 MB. That is, every block which we are going to write contains 128 MB size. Okay. So but here I'll take 64 MB to make the mathematics simple. right? So I'm taking the block size as a 64 MB, right? Now see here, what is my total file size? Prod info file size is 1000 MB. Then what is the block size which I'm using in the Hadoop cluster? 64 MB. So total how many blocks it will contain? It comes 15.16. That is, we'll get the 16 blocks, right? So that is the input data. This one which we are going to write to the Hadoop cluster is going to be divided as a small size of chunks. We call these chunks as a blocks. Then here I told small size. Then how much the small size, right? How much the small size depends upon the property which is specified in a SDF-site.xml for the property dfs.block. So it can be 64 MB, 128 MB, 256 MB, 512 MB, right? So the default one is a 128 MB. Now here I am taking the 64 MB, okay, as a default block size. But generally how much it can be? It can be at the time of the cluster planning, your manager along with the admin. So based upon the cluster size, the data size, so they will plan the what is the block size, right? So based on that we have to specify the block size here. So now my file size is 1000 MB and the block, each block size in the Hadoop takes 64 MB. So there is 15.6, that is 16 blocks are going to be created. So 16 blocks like block 1, block 2, so like block 16. So these 16 blocks are going to be created. And in the introduction session I told that Hadoop uses a commodity hardware. What is a commodity hardware? They are the reusable machines with a low priced machine. They are the inexpensive storage machines. We are going to buy the less priced inexpensive storage machines. So obviously it may goes down sometime, right? So when you write the data in one node, one disk, the disk goes down, then how to get the data, right? We are going to lose the data. So to avoid that, so again in the same sdf-site.xml we have a property. The property is dfs.replication. By default it is set to 3. That is, each block which we are going to write into the Hadoop cluster is going to be replicated 3 times. So now we have a block 1 is available, so it is replicated 3 times. So that is, we have a 3 block 1s are available like this, 3 block 2s are available like 3 block 16. So like this the blocks are going to be replicated. So what is the replication factor? 3. So each block replicated 3 times. Now these replicated blocks are equally distributed to available data nodes. So that, so block 1 placed here as well as the block 1 also placed here, because we have the 3 copies, and the block 1 will also place here. Okay, suppose if this data node goes down, then we can retrieve the block 1 from the data node 2. So if the block 1 block 2 goes down, we can retrieve the block 1 from the data node 3. So that even a data node goes down, so it doesn't make any sense in job processing, right? So like this all the blocks are distributed. So here block 1, block 3, block 4, some like blocks are distributed to all the data nodes. So it follows a rule. So actually how the blocks are distributed, so it follows a rule called block replication placement policy. So as per the block replication placement policy, blocks are going to be distributed to equally to the all available data nodes. So we have block 1 is available in 3 times. So and it's 3 blocks are distributed to 3 different data nodes. So if one data node goes down, we can retrieve the block 1 from the another data node. So like this, how input data is going to written into the data nodes. So now generally everybody will confuse here who are basically beginning in the Hadoop. So don't differentiate the SDFS in data node 1, SDFS in data node 2. It's all together as a SDFS, because these are the data nodes connected to a cluster. So this SDFS, this SDFS, SF, it's together is a SDFS. A single file is a combination of block 1 in the data node 1, block 2 in a data node 2, block 3 in a data node 3. Okay, so don't consider the SDFS individually in each data node. So this is the together is a data node in all the data nodes. So this is the SDFS file system, right? So when we represent SDFS, we represent SDFS together as a three data nodes. This is the SDFS. So my total input data is available in disk 1, disk 2, disk 3, where disk 1 is in data node 1, disk 2 is a data node 2, disk 3 is a data node 3. Okay, so like this the file is going to be written to the data nodes. So now why we are calling this as a data nodes? Because the actual data, the content of this file, this is the data, is going to written into this data nodes, these nodes. So that we are calling these nodes as a data nodes, because the actual data, right, so which we are going to process our input data resides here. So we are calling these nodes as a data nodes. Fine. So like this I'm going to write the files to the Hadoop cluster. So I told that I wrote a command copy from local. So what is the file name? prada.info.txt, and I want to write this file to some Rajesh directory. Yes, the file is going to turn into the Rajesh directory. So I'm keeping writing the multiple files to the data nodes. Okay, you're writing. So after that, if you want to locate a file, then where you have to search? I'm having 100 node clustered, and my input data, whenever I'm writing the files, all the files are going to divide as a small size of chunks. They are going to create as the blocks. The blocks are written to the data nodes. At finally, when I'm trying to retrieve the data, then how I need to find out the file? I need to search in each data node? No. Now we need some another node where we can able to write the reference. So we are taking one more node, which we are calling it as a name node. We are calling it as a name node. So in the name node, what we are going to write? We are going to write the reference of the data. So or you can say index of the data, right? It's a name node. So in the name node, I'm going to write, right, sorry, reference of the data. So whatever the data I'm going to write here, so that is going to be written here. That is here. Now I'm going to write a file. So where I wrote a file, so I'm having a file. So that is a prod_info.txt, right? So where I have copied this file? So this file Rajesh is a directory. In this Rajesh directory, I have copied the file prod_info.txt. Right, so who is the owner of this file? Rajesh. He belongs to the group Hadoop. The file size is 1 GB, and this file is read write executable for everyone. So this information is written into the name node. So now see here what name node contains. Name node contains like metadata of the data, metadata, that is index of the data. So whatever the data we are going to write into the data nodes, that file's information is written into the name node. So that is in this name node, so we'll have a path Rajesh and the file name, and who is the owner, he belongs to which group, what is the size of the file, and what are the privileges to that particular file. So that is written into the name node, and all these data nodes are connected to the name node. Okay, so now whenever you are going to write a new file to the Hadoop cluster, then the file is written into the data nodes. The file reference or the file information or the file path is going to write into the name node. So now what name node contains? Name node contains index of the data in data nodes, or you can say the reference of the data in a data nodes, or in a simple words a tree kind of the structure, the directory name, subdirectory name, and the name of the file, and owner of the file, he belongs to which group, what is the size of the file, and what are the privileges given to that particular file. So this is written into the name node. So name node doesn't contain anything. Name node contains only this metadata. Okay, so now this is the Hadoop cluster with a one name node, which we call it as a master node. So these are the data nodes where actual data resides in the form of blocks. Okay, fine. Now we wrote the data to the Hadoop cluster. Now the client wants to run a job. The client means the user wants to execute a one program. So he wants to write a program in Hive. So this what he client did. So he took his terminal, and in the terminal he wrote a query like this: select star. We'll take count to star. Select count star from prod info. So the client entered a query. When the client enters a query from his desktop machine, then in a name node we'll have a another process available, that is a job tracker. So in the name node we have a job tracker is available. Now what job tracker will do? This job tracker will always take the request from the client. So job tracker's responsibility is to take the requests from the client. So the job tracker now goes to the name node. Sorry, job tracker goes to the client and takes the request from the client, and it takes a request from the client. Then it has to locate where the data related to prod info is available. Where it finds it, this is available in a data nodes. Which data node it is available, in which directory it is available. So that is written into the name node. So first job tracker takes a request from the client, then goes to the name node. In the name node, it will identify in which data node the blocks related to this file is available. Then the job tracker comes to that particular data node. Now, so here the block one is available. Now, in each data node, we have a task tracker is available. Okay, in each data node, so we have a task tracker is available. It's a process, right? The task tracker is available. So now what the task tracker will do? Job tracker assign the job to the task tracker. Then the task tracker will execute the job. Okay, so job tracker searches the in the name node where the blocks are available, then comes to that particular data node and assign this job to the task tracker. Then task tracker will execute the job. Once the job is successful, then the task tracker will give the output to the job tracker. Then the job tracker submits it to the client. Okay, so as long as task tracker is executing the job, it says, hey Mr. Job tracker, I am working, please wait. So task tracker, as long as it is working with the job, but then the task tracker sends the heartbeats to the name node. It sends heartbeats means it says, yeah Mr. Job tracker, please wait, I am working with the job. It will continually sends a messages heartbeats to the job tracker, please wait. So then job tracker is in a wait position. So until the task tracker complete the job tracker is waiting for the output from the task tracker. Suppose task tracker is not sending the heartbeats to the job tracker, then job tracker thinks that maybe this particular task tracker is down or this data node is dead. Then job tracker goes to another data node where the same blocks are available. Then it will assign the job to that task tracker on that particular data node. So now, so if this task tracker is not sending the heartbeats, then job tracker thinks that okay, it is dead. So then it goes to another data node where the same block is available. Then it will assign the job to that particular task tracker. Now this task tracker is executing the job. Now what this task tracker will do now, as long as it is running the job, it will send the heartbeats to the job tracker. Mr. Job tracker, my dear friend, please wait, I'm working on this. So it will send heartbeats continuously to the job tracker. So as long as task tracker is working, job tracker is in a wait position. So once the task is completed, then the task tracker will give the output to the job tracker. Then the job tracker submits this back to the client, right? So here in a Hadoop cluster, so job tracker responsibility is to process the job, take the request from the client, and locating the data into the name node and navigating to the data nodes, assigning the job to the task tracker and monitoring the task tracker, then get the response from the task tracker and submitting the output to the client is the responsibility of a job tracker. Then what the task tracker has to do? Task tracker responsibility is to execute the job given by the job tracker and sending the heartbeats to the job tracker as long as it's working. So this is the responsibility of a task tracker. Okay, now if your data node goes down, nothing is going to be happen because the same blocks are available. But if you lose the metadata, if name node goes down, see here in a Hadoop cluster, name node is only the reason for the cluster down. So we can say that name node is the only reason for the single point of failure. If one says that Hadoop cluster is down, it means that name node is not available. Okay, so only the reason for name Hadoop cluster is down, that is going to be the name node. So name node is a single point of failure in a Hadoop cluster. So then what we are doing here, we are taking another node which we are calling it as a secondary name node. But people thinks that secondary name node is a backup node. It's not a backup node. It's a right, so whatever the data we are writing in the name node, so that we return to the secondary name node, but we are not getting complete data here. See here, I'll show you. So this one we call it as a secondary name node. Okay, so what now, see here, whenever the checkpoint occurs, right, whenever the checkpoint occurs, the snapshot of the name node is updated into the secondary name node. So consider right now the 10:30 checkpoint occurred. So then whatever the snapshot of the name node 1, the content of the name node 1 is updated into the secondary name node. Now next checkpoint time is 11:30. But because you are the DBA, you know very well about this, correct? So 10:45, your name node 1 goes down. Then in the, because the data which I wrote between 10:30 to 10:45 is not written to the secondary name node, and right, how we are going to retrieve the data? We are going to lose the data, correct? So at this time, how to retrieve the data? So we are not giving the complete high availability in this case, right? So because you are the DBA, you work on hard backup and cold backup, right? So you have the archives are there, so redo logs are there, so you are going to retrieve, but we don't have anything available yet, so you need to lose the data. So whatever you wrote between 10:30 to 10:45, so it's very difficult. So that is here, the what is the issue here? Two things. Now in this architecture, we are not giving the 100% high availability, because at some point of the time we are going to lose the data even though we are having the secondary name node. And other one is, see here, observe what the job tracker is doing. As long as task tracker is executing the job tracker is waiting for the task tracker's output. So in this architecture, the two things, what are the two issues here? The parallel processing not taking place, correct? Right, parallel processing is not taking place because job tracker is taking processing only one request at a time. The second one is, we are not giving the high availability. At some point of the time we are going to lose the data. See, these are the two issues in this architecture, right? So there is no parallel processing, so because job tracker always runs only one job at a time, then so there is no high availability. Okay, so this is the architecture generally we used to have in a Hadoop before 2.0. So this architecture we call it as a map reduce architecture. So the map reduce involves job tracker and task tracker. So when you have a map reduce is there, so you are going to get the two things. One is a parallel processing is not happening here, and high availability is not happening here, right? So this is generally we are having in a Hadoop before 2.0. Then Hadoop 2.0 onwards, right? So Hadoop 2.0 onwards, that is Hadoop version 2.0 onwards, instead of the MapReduce, we are using yarn. What we are using? We are using yarn, which stands for yet another resource negotiator, which stands for yet another resource negotiator. So we are using yarn. So then what we are doing here, it's very simple. See, previously there is a one employee has to do all the jobs. Now what I did, the same job role for that employee I divided for the two people. Now the two people are working, that is whatever the job tracker is doing here. So in the Hadoop 2.0 we have the two processes available. One is a resource manager and we use a application master. So instead of the job tracker, now we use a resource manager here. So in Hadoop 2.0 we use, instead of the job tracker, we use a resource manager and application master. So no job tracker now. Then see, first client resource manager takes the request from the client. Then a resource manager locates in the data node, name node, where the blocks are available. Then resource manager goes to that particular data node. So now here, instead of the task tracker, we have a node manager. So we don't call here task tracker, we call it as a node manager. Then resource manager will create the resources, right? It will create some resource for to run the job, and then resource manager says, yes Mr. Application Master, now you take care of the job, please monitor the job. Node manager is executing the job. Now it says Application Master to monitor the job. So now who is executing the job? Node manager is executing the job. Who is monitoring the job? Application monitoring the job. So during this time, resource manager can able to take the second request from the client. So then resource manager takes the second request from the client, goes to the data node, it creates the memory containers, it creates the resources, and it tell the Application Master, Mr. Application Master, so this is job 2. Once you finish the job 1, now you take care of the job 2. Then Application Master will be busy in monitoring the job 1, then monitoring the job 2. Now during this time, resource manager can able to take the third request from the client. So in this way, the parallel processing is possible. It's simple. So previously, whatever the job tracker is doing, that job is distributed to the two processes. One is a resource manager and Application Master. So resource manager will create the resources to the run the job. Application Master is going to monitor the job. And instead of the task tracker, so we have a node manager is available. So instead of using the task tracker, we use a node manager. So node manager will execute the job, right? So what the resource manager will do, right? Take the request, create the resource in the data node, and the node manager is going to run the job, and the Application Master is going to monitor the job. So now we have the parallel processing is available. Can we able to run multiple jobs simultaneously? Yes, we can able to run the multiple jobs simultaneously, right? Now we have to get the high availability. To get the high availability, I am taking one more node. So now in Hadoop 2.0, we are not giving much priority to the secondary node. Instead of that, I am taking one more extra node. So I am calling this node as a shared node. It's a different clients will call the different way. So it can be called as some people call it shared node or resource node, high availability node, HA node, journal node, quorum node. So whatever it may be. So it's going to be one extra node. So what we are going to do now, we are making two writes. Whatever you're writing into the name node, the same I'm going to write into the shared node. So every write in the name node will also written into the H node. So at the same time, two writes takes place now. Okay. So now if this name node goes down, obviously we have one more write into the shared node. So our admin, your admin will configure the auto fencing. So we have a concept called auto fencing. When auto fencing is enabled, then if the primary goes down, this name node goes down, so automatically the shared node is up and run. So we are not going to lose the data, and we are giving 100% high availability when you enable the HA, high availability, in a Hadoop cluster. And we have an option is there, auto fencing, so that can be done by the admin team. So once you did that, so if failure of the name node, so obviously the second one is going to up and run. So in this way, we are going to give the high availability of the cluster, right? So that's what from the Hadoop 2.0 we are using yarn. So when we are using the yarn, then the parallel processing is taking place, and we are giving the high availability of the cluster. That means in Hadoop cluster, SDF is running and MapReduce is running. Okay. So then we take this name nodes, data node, second name node. You can have HA node. So these are all known as SDFSs. Then what is a MapReduce here? The MapReduce means job tracker and task tracker. These two we call it as a job tracker comma task tracker. So if someone says to start a job MapReduce in Hadoop cluster, means you have to start the job tracker in a cluster, and you have to start the task tracker in a Hadoop cluster, right? Hadoop cluster is running successfully, means in the Hadoop cluster SDF is running and MapReduce is running. Okay. Suppose I have started the SDFS, but I have not started the MapReduce. Can we able to run the job? No, because SDFS we can able to store the data, but when you want to run the job must be taken by the job tracker or the job must be taken by the yarn. So I didn't started the map reduce in the cluster and I did not started the yarn. Then I cannot able to run the job. So I can able to store the data, but I cannot able to run the job. To run the job, either you have to start the map reduce or you have to start the yarn. Okay, so that is you are starting the yard means you are going to start the resource manager, then you have to start the node manager. Okay, so now always if we are talking about the map reduce in Hadoop cluster, that involves a job tracker and task tracker. So start a Hadoop with a map reduce, then you have to start SDFS, then you have to start a map reduce. Or if it is a start Hadoop which is a yarn cluster, then you have to write the SDFS, then you have to run a yarn. Suppose him says both start SDFS and start map reduce as yarn as well. Yes, we can start SDFS, then start the map reduce, then start the yarn. So in a cluster, both the job tracker, task tracker, resource manager, node manager, right, application, these should all up and run. So there is no issue. It will take, and it's up to you now which job you are going to run. So that particular job runs, some jobs run with a map reduce, some jobs run with a yarn.